presentation, I'll be describing our work to develop a new cloud-based platform for geophysical data. While this is fundamentally an infrastructure project, the implications for the research community are important and a major consideration for our design. As a joint project between IRIS and UNAVCO, the goal of the Common Cloud Platform is to provide a new environment for the data service needs of both facilities. This includes all the collection, curation, and distribution activities of the current and, importantly, the future data repositories, and will satisfy multiple requirements. Common systems for both facilities will lead to a simpler overall system design and thus operational advantages. We also need to be able to scale to future data management needs, and we would like to offer capabilities not possible with the current systems. Finally, we are being responsive to a request by NSF to jointly develop a cloud-based prototype. For multiple decades, the trend of the two facilities has remained a steady increase of both incoming and outgoing data. The combined repositories currently contain a few petabytes of data, consisting of hundreds of thousands of individual data streams. The facilities handle millions of requests per day, distributing more than a petabyte per year. In the coming years, we project a potentially significant increase in the data input for a variety of reasons, from nodal seismology to DAS recordings to increases in GNSS sampling rates. Output data rates will continue to increase as more data are collected, more data-hungry algorithms such as machine learning are employed, and the capacity to deliver data is increased. We have a number of guiding principles for the project, and a few of which I've highlighted as the most relevant to the research community. The first is to design from a new system perspective, informed by uses and needs of the current facilities. In addition to operational advantages, this new system perspective allows us to more easily design for increased capacity and advanced access mechanisms. Next is to support important access mechanisms offered by the current facilities. While we may not be able to offer all of the services of the current facilities, we are very mindful of the implications of such a transition for the research community, and we aim to minimize any interruption in data access patterns. Another is to include capabilities in the repositories to support FAIR data principles at a fundamental level. FAIR principles support proper citation, identification, reproducibility, and other aspects of data creation and usage. While the current facilities have had good support for FAIR principles for many years due to open policies and standards, some of the management systems we use are decades old, and this is an opportunity to incorporate features such as data licensing, persistent IDs, and more as first-class characteristics of the datasets. A project board has been formed to oversee the design, development, and implementation of the platform. To ensure that the system will meet the combined needs of the research community and the facility operators, the board is composed of research community representatives, technical facility staff, and facility management. Researcher representation is rooted in the strong community governance structures of both organizations. To further ensure broad platform design and application, technical staff from both UNAVCO and IRIS are involved in all teams. Each team is joined by cloud and data management experts from NSF's CI/COE project, and we are very grateful for their help. For the past 8 months, we have been focused primarily on planning, understanding the scope, and development of requirements. In that time, we have developed and documented use cases and workflows based on the current use cases and future expectations, and a concept of operations detailing the current context and conceptual model for the future system, and high-level requirements for the system. We are currently focused on platform component design, an analysis of potential cloud providers, and the development of a common metadata schema and data container. One of the next major steps is to complete the high-level platform design, which involves determining the architecture of each component and of the entire system. Another significant activity is the cost-benefit risk analysis of different potential cloud service providers. This analysis will help us determine which commercial or academic provider is the best fit for our platform and allow us to estimate costs. An important feature of multi-data type platform we are building is the ability to discover and access across these various data types, which is best served by common metadata and vocabulary. We have embarked on an exercise to define common geophysical metadata characteristics and the schema to support them. To ensure that the results of this work are useful beyond our platform, we are working to base the work on larger standards and definitions. As component design matures, we will ramp up prototyping efforts in order to determine the best technological fit for our needs. What does this project mean for the research community? The CCP is a large project, the reimagining of a data management platform for SAGE and GAGE, which will allow for integrated multi-domain geophysical data access from a single facility, a design with cost-effective operation and growth potential, services and capacity not possible with the current systems. For example, the ability to transfer large volumes of data, hundreds of terabytes, and burst capacity when and as needed for spikes in activity. An exciting potential for supporting research data processing in the same cloud environment as the data by avoiding over-the-internet transfer. Also, the opportunity to develop a culture between facility staff, which are currently separate. There's also the opportunity to address legacy technical debt. That's it. Thank you for listening, and I'll see you in the live session.